For this question, we want P to be a point on the graph of y equals x squared minus 4, which is a parabola. We want to express the distance d from that point to the origin as a function of x. So let's make sure you understand what we're trying to do here. We have this parabola. We have this point 0, 0. We have this point x, y. We want to find the distance from 0, 0 to x, y as a function of x. So that distance d, I want d to be a function of x. And then once we have that, we're going to use it to answer a few questions. So let's take a look at our at Desmos and see what we can do there. So looking at y equals x squared minus 4. There's our parabola. Looking at the origin 0, 0. We want the distance from some point on that parabola back to 0, 0. And eventually, we're going to ask the question, what point on this parabola is closest to 0, 0? So just think about that as we're working through this. But first off, just pick a generic point x, y. We want to find the distance from 0, 0 to x, y. Try to draw a better parabola this time. So from 0, 0 to x, y. 1, 2, 3, 4. 1, 2, 1, 2. Something like that. If I pick a point up here, x, y, I want to find the distance from 0, 0. So 0, 0 is here. And again, here's our distance. So you may remember from a previous course that the distance squared is what? Is the change in x, x squared, x, the second x minus the first x squared, plus the second y minus the first y squared, or the distance then is the square root of that. That's your distance formula that you may remember. To get us ready for calculus, I prefer this notation. I prefer to say that the distance is squared is the change in x squared plus the change in y squared. And you can see that if I pick any 2 points, right? This would be the change in x. This would be the change in y. And this would be the distance. So we get that directly from Pythagoras. So in my world, I prefer to think of the formula this way. Distance is the square root of the change in x squared plus the change in y squared. But whichever formula you use, you can see it's going to be the same way. So if we're looking at this picture, from 0 to x, the change in x is just x. From 0 to y, the change in y is just y, or if you like, x minus 0 squared plus y minus 0 squared. So what I get for my distance formula, from 0, 0 to x, y, from 0 to x, change in x is just x, or x minus 0 is x. From 0 to y, or y minus 0 is just y. So we get this formula. We get the distance is the square root of x squared plus y squared. But remember that this parabola is defined by the rule y equals x squared minus 4. So I can rewrite my formula as d equals the square root of x squared plus y squared, which is x squared minus 4 squared. And this should give me a function, which will tell me the distance from the origin to any point x, y, just as a function of x. So the distance will be a function of x, which we're going to do some analysis with, which again is the square root of x squared plus x squared minus 4 squared. Now let's look at Desmos again. Let's look at the graph. I want to pick a point on the graph for us to analyze. And the point I want to pick is 3, 5. And we're interested in the distance from the origin to that point 3,5, certainly not the closest point. What's the change in x? 3. What's the change in y? 5. So knowing that, we can construct the distance. So from 0, 0 to 3, 5, using our geometry, distance from 0, 0 to 3, 5, right? x2 minus x1, if you like, 3 minus 0 squared, plus 5 minus 0 squared, square root of 9 plus 25, which is the square root of 34. And let's get a decimal approximation of that. For that, I will do what? We'll take a look at the graphing calculator, which I'm just pulling up right now. So I will jump there to get a decimal approximation. I want the square root of 34, which you can see I've done before. Let me clear that. I'll do it again. Square root, second square root of 34 gives me a decimal approximation of 5.83 approximately. Now, we also had a formula, if you will, right? We determined that formula earlier. The distance as a function of x was the square root of x squared plus x squared minus 4 squared. So I'm interested in the distance to 3, 5. That would be f of 3. And you'll see we're going to get the same answer. F of 3 is the square root of 3 squared plus 3 squared minus 4 squared. Square root of 9 plus 9 minus 4, 5 squared. Square root of 9 plus 25, which is, of course, the square root of 34, or about 5.83. But what question do I want to know? I want to know what point on the parabola is closest to 0, 0. And what is that shortest distance? That's what we're looking for here. What point is closest to 0, 0, and what is that shortest distance? If we had a guess, maybe around here, just eyeballing it. So somewhere around an x of 1.75 is my guess. But we'll go ahead and run through our function. So what do we know? This is our function. We're going to minimize that function. Find the x value that makes that smallest. To do that, I'm going to put that into my graphing calculator, into the y1 function. I'm going to say y1 equals the square root of x squared plus x squared minus 4 squared. That's what's going to go into the graphing calculator. We're going to find the minimum value of that eventually. So let's jump back. Let's go to the y equals. And I'm going to plug that in square root of x squared plus parentheses x squared minus 4 squared, or to the second power. So that should be it. So if I plug in 3 for x, 3 squared 9, 3 squared 9 minus 4, 5 squared is 25. I should get that same square root of 34. So just as a little check, vars, arrow it over to y vars, function, we have y1. We want to see if I plug in 3, I should get the same answer. And I do. But what I really want is I want to look at this function. I want to find out what is its lowest value. So I'm going to graph it. And I like to work with zooms first So let's try Zoom Decimal. Let's try Zoom Decimal number 4 and see if that gives us a nice enough image. Aha. That looks like the smallest value. That looks like the smallest value. So we're going to go to second calc, minimum, enter. A little bit to the left of the smallest value, a little bit to the right of the smallest value, guess, and 1.87. So I believe that's sort of what we thought it would be. So where it's the closest, we're getting an x of 1.87. X is approximately 1.87 and y is about 1.94. That's the point on the parabola that's closest to 0, 0, approximately. So let's look at that on Desmos and see if we believe that. 1.87. In that neighborhood. So could you believe that's the closest point? I can zoom it in if I can get a little closer to kind of see it. Seems reasonable to me. Now, what about that y is 1.94? What did that represent on the graphing calculator? Not the y value. Notice the y value here is negative 0.503. So if we go back to the graphing calculator, what did that y value represent? The y value is that distance, correct? Remember, the function represented the distance. So x is the x value for the point closest to the origin. The y value is the smallest distance. So if we're going to try to answer these questions, right? What point on the graph of y equals x squared minus 4 is closest to 0, 0? Well, the answer to that question is what? Is the x value is 1.87, is the y value is whatever that is. So if we answer that, x is 1.87 approximately. And y would be approximately what? Now it's on the parabola, so that's 1.87 squared minus 4. So let's jump to the calculator and see what we get. 1.87 squared minus 4 approximately. Gives me a y value of about negative 0.503. So we can see that on Desmos. $1.87 negative 0.503. Now, how about the distance? How about the distance? Well, remember, we said the y value from the calculator gave us 1.94. But if I plug 1.87 into that original function, that should also give me 1.94. There's our distance formula up there. So our distance should be f of 1.87, which is the square root of 1.87 squared plus 1.87 squared minus 4 squared. Again, approximately, since we're approximating everything. So let's jump to the graphing calculator one more time and see what we get. So square root of 1.87 squared plus parentheses 1.87 squared, x squared minus 4, whoops, hit the wrong button there, minus 4, it's x squared plus y squared. Remember, x squared minus 4 is the y value, then square that. And hopefully we'll get the same thing that we had on Desmos for our distance, excuse me, on the graphing calculator, which was 1.94. And I'll show you what I mean by that in a minute here. 1.94. So again, where did that 1.94 come from? Second calc, minimum value. We're moving it a little bit to the left of where it hits the bottom, a little bit to the right of where it hits the bottom, close to where it hits the bottom. Excuse me, I wanted the minimum one more time. Second calc minimum, a little bit to the left of where it hits the bottom, a little bit to the right, and close to where it hits the bottom. And the x of 1.87, the y, the 1.936, the 1.94 is the shortest distance, because remember, y was a function of distance. So indeed, the shortest distance is about 1.936, or whatever that gave us. That's our shortest distance. Shortest distance. So that could be called the distance from the origin to the parabola. And the point that is closest is this point here, is x is 1.87 and y is negative 0.503.